Hello friends, I am Dr. Lokesh Desrai and in this video we are going to discuss how to compute paired sample t-test in SPSS. So let us understand what is the purpose of paired sample t-test. Paired sample t-test is used for comparing the mean scores where one group of individuals or sample is repeated for measuring a particular variable of interest. In other words, it is also used to ascertain a significant difference in the means of two related samples. It is used to examine the difference in mean values before and after the treatment. Now, this diagram also illustrates the concept of paired sample t-test. The same group of participants are there. Now, between these same group of participants, two observations are recorded. One observation before the treatment measured at time point 1 and second observations given after the treatment measured at time point 2. And we are going to incorporate the same dependent variables and the same conditions and treatment apply in the experiment. At the end, we are going to measure whether a significant difference exists for a dependent variable between before the treatment and after the treatment. So if these kind of situations you can find in an experiment, then you should go for paired sample t-test. Now, what are the examples of paired sample t-test in business research? To compare consumer brand awareness before and after an advertising campaign to examine whether the campaign significantly improved awareness. So now the treatment is campaign and the variable of interest is brand awareness. Second example is to measure customer satisfaction level before and after the implementation of a new service policy in a company. So in this case, the treatment is new service policy and the variable of interest is customer satisfaction. The third example is to compare employee sales performance before and after a sales training program to evaluate the effectiveness of the training. So the treatment given is training program and the variable of interest is sales performance. Similarly, the next example is to analyze monthly sales of a product before and after a price reduction to determine whether the price change significantly affected sales. So the treatment is price reduction and the variable of interest is sales of product. So in these all examples, you can evaluate that the groups or the sample remains the same and one treatment we are going to apply and the difference in the observations are recorded two times. First one is before the treatment condition and second is after the treatment. And we are going to examine whether a significant difference exists between these two conditions for a dependent variable. So now we are going to discuss what are the main assumptions of paired sample t-test. Designing experiment is an important assumption. It should be under the controlled environment and repeat observations are recorded. Dependent variable must be metric scale. It means it should be an interval or ratio based. Variability between the paired data. It means the statistics of the paired sample t-test is computed based on a difference between these two scores. It means before the treatment and after the treatment. The difference is required to examine and the statistics is based on the differences of this paired data. And we are also going to compute the normality of the differences. Now, what are the steps to execute paired sample t-test in SPSS? Data entry in SPSS according to the survey or problem given, framing null and alternative hypothesis, create a new variable indicating difference in the score before and after the treatment for a dependent variable. It is a very important step because we have discussed one sample t-test and independent sample t-test. In that, we are going to examine the test statistics based on the observations we found in the survey or the observations which have been given in the problem. But in the paired sample t-test, you are required to compute a new variable, that is differences in score before the treatment and after the treatment, and that difference is based for a further calculation. Examine the assumptions. Normality test by using the case one sample test for the newly created variable, and interpretation of outputs are paired sample statistics, paired sample correlation, paired sample test statistics, decision based on p-value, and then reporting the final results. Now, what problem and questions we are going to discuss? The dataset graduate.sav contains the CGPA score of 90 students from a business school. After conducting an extra tutorial program, the new CGPA of each student was recorded again. Using this dataset, examine whether there is a significant difference between the CGPA of student before and after the tutorial. So let us understand this problem. How many populations or samples are given in this case? The two samples are given, but the samples remains the same. It means the sample before the extra tutorial and the sample after the extra tutorial. So that is why this test is also called paired sample t-test. What treatment was applied? So the extra tutorial program is considered as a treatment. What is the variable of interest? So variable of interest is the CGPA score. How many samples means will be considered? Two sample means will be considered. The first before the extra tutorial program and second is after the extra tutorial program. And which test is applied? The test is paired sample t-test because a one repeated sample is executed in this experiment and the variable of interest dependent variable remains the same and experiment and in this experiment the treatment is also given, that is extra tutorial. So once all these conditions are met, then we should apply the paired sample t-test. Now we go to the data file. This is our data file in which CGP students registration number is there, CGPA is there, gender is there, and new CGPA is there. So this new CGPA is recorded after the extra tutorials, and this CGPA, old CGPA, is recorded before the extra tutorial. So this is the data entry which we have given like this, and this is the data view. This we already discussed. And the important step is create a new variable indicating a difference in the score before and after treatment for dependent variable. Now, the calculation of paired sample t-test is based on a difference in the score before and after the treatment. So we are going to compute this new variable. So what are the steps? Go for transform, compute variable, and target variable. Target variable means the name of the variable which you are creating as a new. So I give this name difference, and now this difference is based on old CGPA minus new CGPA. So just select CGPA, transfer it in numeric expression, use subtract sign, new CGPA, transfer it, and press OK. So once you press OK, in your data sheet, the new variable has been created with the name of difference. You can see in your data sheet like this. Now we are going to examine the first is normality check. So again, I repeat, the normality in this paired sample t-test is checked by a newly created variable, that is a difference in the score. So go for analyze, non-parametric test, and legacy dialog, and one sample KS test. So once you execute one sample KS test, you can find the normality, transfer CGPA in the test variable box, and then you can find the normality results like this. So this asymptotic significance two-tailed, it is 0.200. This is considered as a p-value. And to check the normal distribution, we develop the null hypothesis as the data follows a normal distribution, and alternative hypothesis is the data do not follow a normal distribution. So what is the thumb of rule? Thumb of rule in SPSS is if the p-value less than 0.05 at 5% level of significance, then null hypothesis H note is rejected, and if it is greater than 0.05, then null hypothesis is failed to reject, and the decision will be in the favor of alternative hypothesis. So in the case of normality check, the null hypothesis is your p-value is greater than 0.05, so we fail to reject the null hypothesis, indicating the condition of normality. Thus we conclude that the difference in CGPA before and after the extra tutorial is normal distributed and can be used for further t-test analysis. Now, after that, we design null and alternative hypothesis for the paired sample t-test. So what is the null hypothesis in this case? H note is there is no significant difference between the mean CGPA of students before and after the extra tutorial. So H note mu before equals to mu after. Alternative hypothesis, there is a significant difference between the mean CGPA of student before and after the extra tutorial, that is H1 mu before is not equals to mu after. So that was null and alternative hypothesis, and now we execute paired sample t-test from the data sheet. So go for analyze, compare mean, paired sample t-test. Now, my first variable, now you have to analyze, you have to transfer your all desired variable in a paired group. So the first is CGPA, select this one, press here, and second is again the new CGPA, select and transfer it. Now option is the results will be executed on the basis of 95% confidence interval, so do not change this one. Press OK, and in the output viewer window you can find the results of this paired sample t-test. The important three tables are there. The first one is your paired sample statistics table, second is paired sample correlation, and third one is paired sample test statistics. So how we can interpret all these are the steps which you are going to take place. So the results of your paired sample t-test will be, the first one is your paired sample statistics. So paired sample statistics, the result is this one. The mean CGPA before the tutorial is 6.17, while the mean CGPA after the tutorial is 6.84 for 90 students. As you can see in the table, this indicates that the average CGPA increased after the extra tutorial program. The table provides descriptive statistics showing an improvement in CGPA after the tutorial, but it does not confirm statistical significance. So this is your first table that indicates the paired sample statistics. And now we move to the next result, that is paired samples correlation. Now the second table indicates the paired sample correlation. Total sample size 90, correlation coefficient is 0.226. This value ranges from minus 0, this value ranges from -1 to 0 to +1, and this is called p-value. So the correlation between CGPA and the new CGPA score is 0.220 with a significant value of 0.032. So it is a very weak correlation because because it is closer to 0, and since your p-value is less than 0.05, so there is a significant positive relationship between the CGPA before and after the tutorial. This means student scores before and after the tutorial are positively related, although the relationship is relatively weak. Now, next table is paired sample test statistics table. This table indicates the t-test statistics, but the important point is the calculation of this table is based on the paired differences. So what is null hypothesis we designed for that? There is no significant difference between the mean CGPA before and after the extra tutorial, and alternative hypothesis is there is a significant difference between the mean CGPA before and after extra tutorial. So the t value comes minus 3.4, this with the degrees of freedom 89 and -1 degrees of freedom. So 90 is a sample size, so 90 minus 189, and p-value is SIG two-tailed comes, this is less than 0.001. So this indicates that the difference between CGPA before and after tutorial is statistically significant, because in this case we reject the null hypothesis because it is less than 0.001, right? So now what is mean difference and confidence interval? This value of confidence interval, what does it mean? The mean difference is minus 0.676, you can find here, that indicating that CGPA increased by about 0.67 points after the tutorial. The 95% confidence interval ranges from minus 1.069 to minus 283, minus 0.283, and since the interval does not include the zero, it further confirms that the difference is statistically significant, right? So in this case, the first result is paired sample statistics table that indicates the mean score before the treatment, after the treatment, before the extra tutorial, after the extra tutorial. Sample remains the same, their standard deviation and their standard error of mean you can find in the table. Second is paired sample correlation, that is significant, and this correlation is a very weak, though it is positive and significant because the p-value is less than 0.05 at 5% level of significance. The third table indicates the paired sample t-test statistics, and in this case we reject our null hypothesis because the p-value is less than 0.05. Now, the overall conclusion is the result shows that the extra tutorial program significantly improved the CGPA of the student. So this is all about paired sample t-test. I hope you understood all the execution and interpretation. So thank you so much for watching this video and kindly subscribe the channel for the next videos in this series. Thank you so much.